The next problem that we have here is to smooth out an image. And what does that mean? Well, what the technique that is described in the problem is that if you have an image of size 3 by 3 and you were trying to smooth it out, then this pixel here would be smoothed out by taking the amount of red in this pixel and the amount of red in that pixel, amount of red in that pixel, that one, that one, that one, that one, that one, and averaging them all out. So how do we average them? We add them all together and we divide by 8. And that will be the amount of red that we're going to use in this center pixel. And so we're going to do the same thing with the green and the blue, and then we're going to set that pixel to be the average red, green, and blue of all the pixels around it. And so how do we do that? Well, there were a couple of functions that they went over in the chapter, and the first one would be to get pixel, right? Get pixel. So we're going to say image.getPixel, and I'm just going to write shorthand get p. And what we have is a nested for loop. So we have for row in, and then we have for column in, and up here this is column and this is row, and these are indexed starting at 0, 1, 2, 0, 1, 2. And the way the for loop works is that the for loop creates a temporary variable called row, sets it equal to 0, and then checks if it's less than whatever number we have here, and the number we have here is going to be the height of the image. And then so 0 is less than the height of this image, which is 3, so that's true. And then it comes into the body of the for loop and it creates a call variable and sets call equal to 0 and checks if call is less than the width of the picture. In this case it's 3. That's true. And then we come into the body of the nested for loop, or the inner for loop, and we're doing image.getP, right? And so we'll get p at row column, right? And that would get this pixel here, right? And then when the inner for loop iterates again, call is going to be increased to 1, so that would get this pixel here. And then when the inner for loop iterates again, call will be incremented to 2, so it will get this pixel here, because row doesn't change. Row is always 0, right? Because we are in the first iteration of the outer for loop. And then that's the end of this inner for loop, because call is going to increment to 3, and 3 is not less than 3. That's not true. So it's going to break out of this inner for loop. It's going to come back up here, and row is going to be incremented by 1, so row is not going to be 0 anymore, it's going to be 1. And then we're going to do the same thing for row number 1, which is here, right? So row 1, column 0, row 1, column 1, row 1, column 2, break out of the inner for loop, row increments from 1 to 2, and then we do 2, column 0, 2, column 1, 2, column 2. So this nested for loop is a way that we can iterate through a matrix, right, or this 2D array looking image. And so and so if we're looking at this, it's it's pretty simple how to get this done. What we need to do is we need to get pixel 8 times all around the pixel, right? So we don't need to get this one, right? We need to get this pixel right here. How do we do that? Well, you could see here that this pixel has the same row as the original pixel, but the column is moved to the left, and since the column is moved to the left, we need to subtract 1 from the column, so we're going to say -1, right? So this get pixel here is going to be the pixel to the left of the pixel that we are trying to smooth out. And so we could say p is equal to, or I'm sorry, probably don't want to call it p, probably want to call it left. So we could say left is equal to this get pixel, right? And then we could say, which one do we want to get next? Well, we probably want to get this one up here if we want to move around in a clockwise direction. So we're going to do the exact same thing, and we could say, we can call this variable top left is equal to img.getP of row -1, column -1, right? So that's going to get the top left pixel. And then we're going to continue doing that until we have all of the pixels around the P. right? And so let's say we have all of them, dot, dot, dot. Now what do we want to do? Well, let's say we're here out of the nested for loop. I'm sorry, no, we're not out of the nested for loop. We are still inside this inner for loop here. And what we want to do is we want to average the red of all of the outer pixels. So how do we get the red of all of the outer pixels? Well, let's start with L, and we could say red is equal to, or maybe call it new red, is equal to left dot get red plus TL dot get red. And remember, get red is going to give you the intensity of red, which is a number from 0 to 255. And I'm going to say dot dot dot, right? Because we're going to do that not with just these 2 pixels, but we're going to do it with all of the 8 pixels that we got. And then we're going to divide all of that by 8 to get the average, right? And then we're going to do that for new green and new blue. Right. And once we have all of those new reds, new greens, and new blues averaged out, well, then we can make a new pixel, right? And I think there's a function called new pixel that takes in a red, green, and blue. We're going to put this red value here, the green value here, and the blue value here. So we'll say NR, NG, NB. That makes our new pixel, and we can call that new pixel. And then finally what we want to do is we want to set that new pixel with the new red, green, and blue that we made right here as that center pixel. And that center pixel, if you forgot, is just row column, right? And so what we can do is we can do set pixel. So I could say image dot set pixel row, I'm sorry, I think it's column row. All of these actually are column row. I have them backward. So you want to switch those all around. It should be column -1 row, column -1 row -1. Right? And so we come here column row, and then set pixel takes a column, a row, and it takes the pixel that you want to set at that column and row. So we're going to put the NP right there, the one that we just created with the new red, green, and blue values. And then we're done, right? We run this, and what you're going to see is that it doesn't work. Okay, and the reason why it's not going to work is because when we first start this nested for loop, the first iteration of this outer for loop, row is going to be set to 0, column is going to be set to 0, and we're going to be considering this pixel right here in the top left corner of the image. And then it's going to come in here and it's going to run the first get P, right? And the first get P is the left pixel, and that's going to get row 0 right here, and it's going to get column 0 -1, and 0 -1 is -1, right? So what this is trying to get is this pixel right here to the left of the one that we are considering, and as you can tell, there is no pixel there. And so since there is no pixel there, this will error out. So that is an issue. And as with all problems in computer science, you can solve them in many different ways, and this is one way that you can solve this issue. Okay, let me go ahead and draw out a bigger version of the image. Okay, so this is our image, and these are our columns, these are our rows, and we start at 1, 0, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6, and our for loop is going to start with this one, right? And then it's going to consider that one, that one, that one. It's going to move to the right. Once it finishes, row is going to be incremented. It's going to consider that one and move on to the right, and so on as we go down the image, right? Now what's the problem? The problem is that we need to do something different when we get the corner, right? The top left corner, we need to not consider the pixels on the top or the left side, and we don't consider them because they are not there. They don't exist, right? If we're in the top left corner, the only ones that we want to average are the ones below it, the one to the right of it, and the one to the bottom right of it, right? Because those are the only ones that are around it and that exist. So I'm going to put a circle around this pixel saying that he's special. I need to make a special case for him. And then if you notice, all of these pixels from column 1 to column 5 are all the same case as well. They are all special. but they are all the same kind of special. And why? Because for this one here, we need to get the left, bottom, bottom right, and the right. Right? And we need to average all the red, green, and blues of those pixels. Same thing with column 2, 3, 4, and 5. Right? They all are going to average the same pixels relative to the new position that they're in. And then we can notice that the corners, all of them are special cases. So I'm going to put a circle around those guys. And then if we think about it some more, these are all a special case. So are those. So are these. Right? And all of these in the middle are all a special case. Right? The ones in the middle are the ones where you need to average all of the red, green, and blues of all the pixels around it, because they all have pixels around it. Okay. So notice here that now our computer needs to make a decision. Right? If I'm in the top right corner or top left corner, I need to do something special. Right? If I'm in the top right corner, I need to do something else that's special. Right? If I'm in the bottom right corner, I need to do something else that's distinct and special, and so on for each of these circled cases. And so in this case, our computer needs to make a decision. And so how does our computer make decisions? How does any program make a decision? What's the only way that it can make a decision? It's with a branch. Right? So we only have 3 tools when it comes to computer science. We have variables, branches, and we have loops. Those are the only 3 tools that we have. We can use them in different combinations to create innovative and complex solutions, but that's all we got, right? So of those 3, what can we use to solve this issue here of making a decision is a branch, right? And so we're going to have a branch statement inside of our nested for loop, right? And we're going to say if, and if what? Well, in this case, I want to say if I'm considering that top left corner. Right? And so how can you create a Boolean expression in this if statement that will run or be true when the nested for loop is considering the top left corner? Well, what you can do is consider the row and column variables. Right? So I could say if row is equal to 0 and column is equal to 0. Right? This is only true if I'm in the top left corner. Right? And if that's true, then I'm going to get the right pixel, I'm going to get the bottom right pixel, and I'm going to get the bottom pixel. Right? And I'm going to average those 3 red, green, and blues. Okay. And we're going to similarly use the same strategy for the other corners. Right? These are all distinct. So else if row is 0, column is the image dot width minus 1, that would be 6, right? Because image width gives you how many elements are in the image wide, right? So it's 1, 2, 3, 4, 5, 6, 7. So image width would give us 7, but we want 6, so we say image width minus 1, right? Okay. So to get the top right corner, we would say if row is equal to 0 and column is equal to image width minus 1. Okay, and same thing down here. We would do, or let's consider this one here. We would say if column is equal to 0 and row is equal to image height minus 1 for the same reason, right? Because the height would be 7, and then we don't want 7, we want 6, right? So we minus 1 from the height. And then this one over here would be image width, column is equal to image width minus 1, and row is equal to image height minus 1. Right? Okay, so we have the corners. Those are fairly straightforward, and we would do something special based on all of those. Right? For this one here in the bottom right corner, we would get the left pixel, we would get the top left pixel, and we would get the top pixel. Take all the greens, average them out. Take all the reds, average them out. Take all the blues, average them out. Right? To get a new value, and then now comes this big old box here, right? How do we create a Boolean expression that will be true for all of these values? Right? Well, if you notice here, this is a range of values, right? We want from 0 to image width minus 2, right? Since image width is 7, all right, image width minus 2 is 5. So we want all of these. We want 1 to 5, right? If our image width was 100, we would want 1 to 99. Right? And so how do we do that? Well, this takes us back to elementary school. And so if we remember this number line, right, and I take a look and I do this to it, and I do this to it, right? These two drawings here, the lines with the arrows, represent inequalities, right? So I'm going to write this out mathematically. It'd be x is greater than, not greater than or equal to, right? Because if I color it in, then it's greater than and equal to. So I'm going to say greater than -3. And since we have another inequality here, I'm going to say and x is less than 2. Right? So if both of these inequalities are true, then which numbers am I talking about? Right? Well, I'm talking about these numbers right here, 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 and here. So I'm talking about -2, -1, 0, and 1. Right? So we can create two inequalities, and that will represent a range of numbers. Right? So that's what we want to do up here when we want a range of numbers. So let's go ahead and do elif, and we do want to do elif, not if, because only one of these conditions is going to be true at a time, right? And so when you only have one possibility, then you always want to use elif, right? So we're going to say elif, and we're going to say row equals 0, because that's definitely going to be true for this top section here. And we're going to say and I like to put parentheses. I'm just going to write it down here because I don't have any room to write it over here. But we need to write two inequalities now. So we're going to say column is greater than 0, right? That means 1 and above. And column is less than image width -1. Yeah, that's right. So image width -1 is 6. Right? And so greater than 0, less than 6, which numbers am I talking about? I'm talking about 1, 2, 3, 4, and 5. Right? And so in this case, what do I want to get? I want to get the left, I want to get the bottom left, I want to get the bottom right, and the right pixel. Right? Then get all of the red, greens, and blues, average them out, so I can have those three values to make my pixel downstairs. So that's the strategy that we're going to use to get a range of numbers. Right? And you can use that strategy here, here, and here. And now for these middle section, you need to use two ranges of numbers. Right? A range for the columns and also a range for the rows. Okay? So yeah, that's about it. And let's say that we have all of that, and we have calculated our new red, our new green, and our new blue in these variables here, right? Then what are we going to do? We're going to say new pixel is equal to, what is it again? New pixel, I think it is. New red, new green, new blue, and then we're going to use set pixel. So we're going to say image.set pixel column row new pixel. And if you have all of your if statements set up correctly, then when you hit run, it should run through all of the pixels, getting special pixels for each of the special cases, and smoothing out your image in the long run by taking the red, green, and blues of all the pixels around the pixel, and then creating a new pixel for that position. So good luck putting that together.